Hello everyone! Last week we learned how to compute the derivative of a function using the definition that involved a limit. In the following videos we will learn how to compute derivatives without having to rely on computing the limit every single time. The first functions that we will learn how to find the derivative of are the function that has the shape of being x to certain power n. Okay, so the formula is the following. If f is equal to x to the n, then the derivative will be n times x to the n minus 1, where n can be any real number you choose. So notice the formula says, so if I have x to the n, then the coefficient of the derivative will be equal to the power, and the new power will be 1 less than the original function. Let's see some examples. So in the first one we have f of x equals x to the 13th. So to find the derivative we simply follow the formula. So in this case n in our formula is equal to 13. So we will get that the derivative it's equal to 13 times x to the 13 minus 1. And then we can subtract this and find that the derivative is 13x to the 12th. The second example might seem a bit tricky because now n it's a negative number, but the formula follows the same way. So we will get that the derivative is minus 4, that is our n, times t to the minus 4 minus 1. Then we put everything together and we get that this is minus 4t to the negative 5. And finally, we can do the same thing when n is, for example, a fraction. So in this case, 1/4. So in this case, the derivative will be s prime of u will be equal to, take out the exponent and subtract 1, and this will be equal to 1/4 u to the negative 3/4. Okay, so we can follow this formula for all the functions of the shape x to the n, where n is any real number. The second rule we will learn is the coefficient rule. So essentially this is saying that if I have a function which is a constant times another function, then the derivative of this will be simply take out the coefficient and find the derivative of what was inside. So for example, here we have f of x equals 2 times x cubed. Okay? So this formula is telling us that the derivative of this function will be 2 times the derivative of the function x cubed. But now, from the previous slide, we know how to find the derivative of x cubed. So in the end, the derivative of f will be 6 times x squared. For the second example, we have to remember that the square root of t is equivalent to, say, t to the 1/2. So our function can be written also as 7 times t to the 1/2. So now the derivative of this will be equal to 7 times the derivative of t to the 1/2. But from the previous formula, we know how to compute this. So this will be equal to 7 times 1/2 t to 1/2 minus 1, which is equal to 7/2 t to the minus 1/2. The next rule we will use is what is called the sum and difference rule. So essentially, if our function is the sum or the difference of two functions, then its derivative will be equal to the sum or the difference of the derivatives. So let's see this in the following examples. So first we have that f of x is equal to x squared plus x to the 1/2. So this formula is saying us that to find the derivative, we simply need to find the derivative of x squared plus the derivative of x to the 1/2. And we know how to do this from the previous formulas. So we will get that this is 2x plus 1/2 x to the minus 1/2. The second example involves all the formulas that we've learned so far. So let's try to do this. So first of all, we need to use the sum and difference rule to get the following. So the derivative will be equal to the derivative of 3x squared minus the derivative of 4 times x to the minus 1 plus the derivative of 5. And again, we know how to do this because this will be 3 times the derivative of x squared, which is 2x, minus 4 times the derivative of x to the minus 1 plus the derivative of 5, which is a constant. So we already learned that the derivative of this is equal to 0. So putting all these together, we get that this is 6x plus 4x to the minus 2. So far we have the following 4 formulas for derivatives. The first one, which is a consequence from the exercise we did last week, is that the derivative of a constant is equal to 0. So that is what this first one is saying. The second one is that the derivative of x to the n is equal to n times x to the n minus 1. The third one is that if our function is being multiplied by a constant, we can take the constant out and find the derivative of the second function involved. And the last formula we learned is that if we have the sum of two functions or the difference of two functions, then its derivative will be the sum or the difference of the two functions.